Hey, so this recording about EV and SE has taken, this will be the fourth video. Um, and I apologize for all the issues that I had on Friday, but hopefully this will be the last one because I did not go over an example with using EV and SE average. So I wanted to talk about that. So for this example, I have female BMI, which stands for body mass index. It's just a rating that you get based off of your height and your weight and your age. Anyway, so they have for females age 35 to 55, average BMI is 25.12 with an SD of 5.3. So suppose that BMI is approximately normal, so it follows a normal curve. What is the chance a single randomly selected woman will have a BMI more than 25.5? So if we are just looking at, let me get a different color here. So if we are looking at just the probability of one woman, then we only need to use just this average and this SD, right? So when we plug in the norm CDF, we're wanting, hey, what's the probability that just one woman has a BMI higher than the 25.5? So then the lower bound will be 25.5, upper bound 10,000, and then our mean is our 25.12, and the SD for just a single woman is 5.3. So then when we plug that in, that would be the chance of just one woman, and it should be under 50%, because if you think about the normal curve and the average is right here, 25.12, well, 25.5 will be right above that, right? So it should be less than 50%, 40-ish maybe, I don't know. Anyway, plug that in and that would be the answer to just one woman. Now, using that same information over here, what if we sample 100 women? Okay, and then we want, what is the chance that the sample average will be more than 25.5? So now instead of looking at a single woman being more than 25.5, you're looking at what is the chance that the average sample of those 100 women is more than 25.5. So we are still going to use, so the EV, let's split this up. So the EV average here is the 25.12, because we still expect the sample average to be what the population average is, right? But the thing that will change is how much we are off by, which is the SE average, or the standard error. So then that will be the SD of the population, or the SD of our box model, divided by the square root of our sample, or the number of draws. So we're actually going to divide it by 10, so then it'll be 0.53. So then when we plug in the norm CDF, it will be, the lower bound will be the 25.12, upper bound, you can keep the 10,000, mean is, no, I did the wrong thing, sorry, you guys probably caught me as soon as I did it, 25.5, because that's what we're finding, what's the chance of. Sorry, and then the mean is the 25.12, and the SD is the SE, which is 0.53. And then you find that probability, okay? So remember, this one was just a single person, but when we're looking at a sample of people, make sure that you find the EV and the SE. Whereas here, we just needed the SD because it's one person. Okay, so that's what I needed to show you for you guys to finish the assignment. It's called EV SE and sampling review. And I made it a quiz in Canvas, but it's not really a quiz. It's just practice that you can take as many times as you need. Hopefully, if you answer no, I thought I had the feedback set up, but I may not. So after you submit it, then I will give you feedback before you try it again if you need to. And then I just wanted to show you that these formulas right here that you will need for your assignment, or that we have used so far, is what is on the formula sheet, is these exact formulas. So I will be uploading these notes to Canvas. If you want to just print them off, you can. And if you have any questions, let me know. Have a good day.